Hello all, welcome to Ferdinand tutorials. Today we are going to be talking about enzymes. Now we said that enzymes is a course under biochemistry, like it's a subject under biochemistry. So when we are talking about enzymes, we say that enzymes are biological catalysts that speed up the pace of chemical reaction, or we can say that they speed up the rate of chemical reaction. Now this enzyme was first discovered in 1978 by Kuhn. Now he introduced the term enzyme to indicate biological catalyst. So now when we are talking about this enzyme, we say that enzymes are produced by all living organisms, including humans, and also present in only in small amounts. That is, these enzymes are present only in small amounts. Even though they are found also in the body of humans, they are present in what small amounts. Now, what are some of the biological importance of these enzymes? Now, enzymes make life on Earth possible. You know why? Because all biological, from conception to the dissolution that follows death, depends on enzymes. That's all biological process from conception to what? Dissolution. Are you getting it? That follows death depends on what? Enzymes. Now the second one is that enzyme regulates the rate of physiological process. That is to say that the defect in enzyme function causes disease. If you have any particular enzyme that has a problem that doesn't function well, it causes a what? It causes a disease. Now the third one is that when enzymes or when cells are injured, enzymes leak into the plasma. Yes, enzyme leaks into the plasma. That is why we say that measurement of activities of such enzymes in plasma is an integral part of the modern day medical diagnosis. I guess it's a function of the modern day medical diagnosis. Enzymes are also used as what? They are also used as drugs. They are also used as biosensors. Enzyme can also be used in cleansing or used as cleansing agents. Are you getting it? In detergent industry. There are many functions of enzymes. We can also say that enzymes are the chemical workhorses of the body. Are you getting that? The chemical workhorses of the body. That's even number one characteristics. Are you getting it? It's number one medical importance of this enzyme. Are you getting it? They are what? They are workhorses. Are you getting it? In the body. So now let's talk about the chemical nature of enzymes. When we are talking about chemical nature of enzyme, we are talking about the properties. How you getting? How did this enzyme started? Now we said that all enzymes are protein except ribozymes. Have you seen an enzyme that is not protein? It is only what? It is only ribozymes. Now enzyme cuts big molecules apart and join small molecules to form big molecules. It cuts the big molecule now and join the small ones to form what? To form big molecules. Now the next one there is that the most of the chemical reactions in the body are enzyme catalyzed. Most of the chemical reactions in the body are enzyme catalyzed. Now the next one there is that, remember that the substance upon which an enzyme acts is called as substrate. I get it. By the action of enzyme, it is converted to product. Now an enzyme catalyzed reaction consists of substrate, enzyme, and the product. I get it. Now the substrate is at the left, the product is at the right. Now the arrow in the middle shows the what? Shows the enzyme. I get it. The arrow shows the what? The enzyme. I don't know if you are getting what I'm saying. So that is it. Now also enzymes are big particles. Their molecular size weight ranges from few thousand to millions. So these are some of the properties of enzymes. There's some of the properties of enzyme. Now to know how enzyme work, physical chemistry of catalyst must be explored because enzymes are what? Catalyst. I don't know if you are getting it. Enzymes are what? Are catalyst. That's why you say that enzymes are biological catalysts. Enzymes are what? Are catalysts. So now when we are talking about catalyst, what do we mean? Now a catalyst does not change the chemical reaction, but it accelerates the reaction. They are not consumed in the overall reaction, but they undergo chemical reaction, or physical change during reaction, and returns to original state at the end of the reaction. And that is why we say that transition theory is proposed to explain the action of this enzyme. Now we use transition state theory to explain the action and activities of enzymes. Now that is why we say for this reaction A to B to occur, for this reaction to occur, energy is supplied. Now this A is an unstable state. This B as a product is a stable state. Let me explain. I earlier said that for this we use transition state theory to explain the activities of this catalyst. Are you getting it? Now when energy is supplied, A is unstable. Now this B is stable. Energy supply is an unstable state. Now energy required for this A to change from this unstable state to a stable state, we call it the what? The activation energy. Activation energy. That's the energy required for A to go from ground state to transition state. I don't know if you are getting it. That is what we call what? Activation energy. Do you understand? So that is why we say that for this reaction to occur, are you getting? For this reaction to occur, we must use transition state theory to explain this reaction. So that is it for catalyst. Now we also have reaction specificity. Are you getting me? We also have reaction specificity. Now this reaction specificity is majorly performed by enzymes. Now that is where we have the reaction specificity. We have the substrate specificity. We have the group specificity. We also have the absolute, okay, let me write optical specificity here. Optical specificity. And we have the absolute group specificity. Absolute group specificity. So these are the enzyme specificity. The specificity of this enzyme. So that means that each enzyme, each particular group of enzyme is specified in their reaction. They have a work they do. I don't know if you understand. So in my next class, we'll be talking about the nomenclature of enzymes. I get you will understand how the International Union of Biochemistry classify these enzymes. I don't know if you understand. You will classify enzymes into 5 groups. You'll see it in my next class. Do not miss out. So thank you for watching this video. Thank you for being here. See you in my next class.